This is a video of the Vehicular Wireless Spectrum Measurement System implemented at Worcester Polytechnic Institute, or WPI, located in Worcester, Massachusetts, USA. This system was used in collaborative research activities between WPI and the Toyota Infotechnology Center USA in order to assess the amount of unused wireless spectrum in digital television bands for emergency vehicular communication networks. The measurement system constructed at WPI for this project consists of an Agilent CSA N1996A spectrum analyzer capable of scanning frequencies ranging from 100 kHz to 3 GHz and as low as -130 dBm. A computer laptop running the custom-built Squirrel spectrum measurement software that controls the spectrum analyzer and gathers data from it using an Ethernet cable. And a Diamond D220 mini discone antenna with an operating frequency range of 100 MHz to 1600 MHz that is connected to the spectrum analyzer via coaxial cable. Assembly of the spectrum measurement system can be easily and quickly performed on any vehicle using these components. The antenna can be mounted on top of a PCB, non-conductive pipe employed as a mast and attached to the back of the vehicle using a bicycle rack. To ensure electrical isolation of the spectrum analyzer, this device is configured to run on battery power, which has a battery life of approximately 2.5 hours. This is done in order to ensure a clean power source instead of being connected to the vehicle's battery supply, which is influenced by the ignition system. On the other hand, the laptop computer is connected to the vehicle's power supply via an inverter device. Squirrel stands for Spectrum Query Utility Interface for Real-Time Radio Electromagnetics, which is a spectrum analyzer software tool developed in-house at WPI. Squirrel communicates with the spectrum analyzer using TCL and over a TCP/IP connection. The GUI accepts details such as the center frequency, the span around the center frequency, and the resolution bandwidth. After the sweep action is performed by the spectrum analyzer, the data points are returned to the GUI in a comma space value format. In its current format, the GUI and the server are written in Java and can be deployed on a variety of operating systems. Given the portability and ease of use of this spectrum measurement system, it is possible to arrive at a specific location, employ the system to quickly collect spectrum data, and subsequently move on to the next location. Consequently, this measurement system is very convenient when assessing the availability of unoccupied spectrum at numerous locations. One application of this spectrum measurement system is the characterization of vacant television channels along the 134-mile stretch of Interstate I-90 in the state of Massachusetts in the United States. This is done in order to obtain a better understanding of the availability trends of vacant channels from a vehicular dynamic spectrum access perspective. This digital television spectrum measurement campaign was conducted by WPI professor Dr. Alexander Wiglinski and his PhD student Mr. Shrikant Pagadarai on June 7, 2009 and June 11, 2009 using this measurement system. Measurements were collected along 48 locations between Boston, Massachusetts and West Stockbridge, Massachusetts along Interstate I-90. At each site, 10 frequency sweeps were collected with a frequency resolution of 20 kHz. Since the goal of this project is to characterize digital television spectrum over several locations along Interstate I-90 in the state of Massachusetts, most sites were chosen to be within a half-mile from Interstate I-90 for the purpose of avoiding interference to the ongoing traffic. The locations of these measurement sites were selected to be approximately 2 miles apart. This activity was supported by the Toyota Infotechnology Center USA. As we can see from these 4 sample measurements, the amount of unoccupied television spectrum available for secondary access by vehicular communication networks varies geographically, with the locations closer to densely populated urban areas having less available spectrum, while those locations in rural areas possessing more unoccupied television spectrum for secondary accessed by vehicular networks. This concludes our video presentation. Thank you.